genetic crosses involving 1:1 and 3:1 ratios. Before continuing with this video, please watch this. It's a video about Mendel's experiment, but in much greater detail, and this is by Khan Academy India English. The link will be provided in the slides, or you could just check the one on the playlist. So about Mendel was not just some random monk. He was quite well learned, and the occupations he held were such as a biological scientist, physical scientist, and mathematician. And this helped him quite a lot because he had so many different perspectives, and it led to his covering about genetics. Last, he was also the director of Moravian Mortgage Bank in the 1870s, and largely a respected figure in the community. So continuing from the Khan Academy video, and I'm using the example of the tall and dwarf examples. Here, let's denote the tall plant as big T and the dwarf as small t. And for anyone watching this video, what is the importance of a big T and small t? If you can recall from the previous video, I'll give you 2 seconds to think about the answer. Alright, so the big T is the dominant allele, so big capital is always called dominant, and the other one is recessive, the small one. As for the first filial generation, and I'm continuing from the video of Khan Academy, the parents are about purebred, and those are the big T, 2 big T's, and 2 small t's, and they are homozygous. Remember that, please. And you see that, and when they're bred together, they're bred in such a way that big T, and I'll point it out, the big T is crossed with that small t over there, and it forms this one. And the result is the same for all the F1 generation, or the first filial generation. And following from the previous example, so the F1 generation are allowed to self-fertilize, where the parents are both heterozygous, so those are big T and small t, so it will result in a new generation of offspring, which we call the F2 generation, resulting in 3 talls and 1 dwarf offspring. But how, is what you're wondering from all this. How did the F2 generation have 1 dwarf variety when their parents are all tall? So let's take a look at their parents. Both are heterozygous, and let's split them up so it is easier to do. Here what we have is that heterozygous, they are combining each other in a certain sequence, like how you expand in maths. Using that one and that analogy, these two over here, these two comes from this parent. And what we want to do is that we want to cross it with this parent over here. What we can do as the big T from this parent, we combine it with the big T from this parent, and also the big T, we combine it with the small t from the other parent. And here, the small t from this parent goes to the small t of the other parent, of course, yes. And what we have is that this one over here, so it results in first the 2 big T's, which is the big T from these two, and these two, and the heterozygous big T and small t comes from this one and that one over there, and likewise it comes for the small t and the big T, and we just arrange it in that way, so always dominant and recessive afterwards, and 2 small t's, and that's how you get the second generation, the F2 generation. And this is just a summary of what Mendel's experiment would look like. Purebred parents, homozygous for each dominant and recessive, and all of them becoming all tall because they all containing all the allele in that one, which is the big T's. Here, as we showed earlier, there's 1 homozygous big T, 2 heterozygous, and 1 homozygous recessive, which results in 3 tall and 1 dwarf. The other way of doing this is using a Punnett square. So a Punnett square is just and this is using the F1 generation as an example. So the F1 generation, you just this is the homozygous dominant. So with this one, you just put each gamete over here, side by side. Sorry, each allele. So you put each, and what you do is that put this one downwards. So you put the big T downwards and the small t over here. Results in two big T's, one small t, or one big T and one small t. And you do it over downwards again. Looking at that one, you go downwards and you go here. And it results in one big T, one small t. And the same goes if you do it like here, and you get one small t, one big T. And here again, yeah, so you get the same goes for the F2 generation. So the F2, you have two heterozygous, so one big T, one big T becomes one big T. This one, well, you know the drill. So like that, and go here, and then go back there, and you go back here. So it just works like a big puzzle, or a small one, depending on what you think about it. Here we have our next video, and we'll try to explain the meaning of the terms genotype and phenotype and assess their importance in animal and plant breeding. We already covered genotype and phenotype, and we're going to assess their importance in plant breeding just right in this next video. Thank you.